Okay, welcome back to another video. As you can see, I did make a start on this a few minutes ago and my pen started to run out of ink. So in this video we're going to be looking at area of a triangle, calculating the area of a triangle using trigonometry. I'd just like to give a big shout out to the GCSE subreddit user _chocolate mango. They suggested this topic and they also supplied the logo for the channel. Oops. I don't know if it's going to show up too well on the camera there. It doesn't help with the way the phone background's quite dark. But yeah, so I've uploaded it onto my Google account. For some reason it's still not showing on the YouTube channel logo yet. Maybe it just takes time for it to come through. But yeah, big shout out to Chocolate Mango. Thank you for being the first to reply with a logo for the channel. I really appreciate it. So, calculating the area of a triangle. It's quite straightforward. You need to remember this formula here, that the area is equal to a half AB sine C. Some people often forget, you know, these letters. They're not random. They're literally in alphabetical order, A, B, C. So you know, after having that pointed out to you, you will probably remember it a little bit easier. But you know, how do you decide what angle C is or what lengths A and B are? Well, that's really easy as well. So in this example here, if we have a length of 5 centimeters and 8 centimeters. And the angle in between them is 75, and we just draw that there with a straight line. Okay, so we want to calculate that area there. Well, it's easy. We say that's a half A, which is 5, B, which is 8, sine C, which is 75. So the A and the B are either side of the angle that we're given. Now we don't know these other two angles here, X and Y. I'm just going to call them. You know, we have no idea what they are. So to work out the area of that triangle, that's the angle we're given. So we need the two lengths either side of it. And then to work this out, then you use your calculator. But first I'm just going to simplify this and say that that is a half of 8 is 4. 4 times 5 is 20. So that's 20 sine 75. And then you need to use a calculator to work that out. So here's my calculator. Hopefully you can see the screen there. It's a bit dusty in that. As you can see, I don't really use it very much. Yeah, that's a bit of an understatement. So 20 sine 75. I should point out there that I didn't make that comment saying, you know, I'm really smart or anything. It's just that normally when I'm going through things with students, I normally just leave it here and let them calculate it. I'm normally too lazy for that. So it's given us an exact value there. 75 is one of these angles that has a weird you know, exact value. So sine 75 is root 6 plus root 2 all over 4. And sine of 15 degrees has an exact value as well. Again, it's very similar. I think it's root 6 minus root 2 all over 4. So yeah, so let's write that out in terms of a decimal. So 19.3 in this case centimeters squared, and that's to 3 significant figures. So that's one example there. Okay, so let's try another one. So we have another triangle, and I should have thought this through a little bit because now I'm not going to be able to put my calculator in the same spot. Oops, that shouldn't be a point there, by the way. Just ignore that decimal point. 97 degrees. Okay, so with this question here, pause the video, have a little go at that. and then we can go through it together. So the area for this is a half this length, 6.8, multiplied by the other length, 7, multiplied by sine of the angle, 97. And then you use your calculator. I'm just going to, I'll put my calculator there. Hopefully the reflection of the light doesn't interfere. Hopefully you all can see that. So I'm just going to do 0.5 times 6.8 times 7, lots of sine 97, and that comes out to 23.6 millimeters squared, 3 significant figures. Okay, so here are 2 examples. Now I'm going to put this sheet here, and I'm just going to check there that all of those numbers are in the correct view. Yep. So here are some more questions. So have a go at each of these, and remember that the formula A is equal to a half AB sine C. Remember here that these lengths A and B are adjacent to the angle C. So in this case here we have 2 lengths. So to calculate the area of this triangle we need the angle between them. Now I'm not going to tell you how to work that out, you should be able to figure that out for yourself. In this example here, is that actually the one that I've went through? Yeah, that's the one that I've went through. But here you see that the angle is between both lengths. This example here, it's between both lengths, so you can just use the formula straight away on that. This triangle here though, the lengths aren't adjacent to the same unknown angle, so you need to calculate that angle before using this formula. And then kind of like as a stretch and challenge type of approach, you can try calculating the lengths of these parallelograms using this. And what I will do is I'll put the answers to all of these questions in the video description, or maybe I'll make another quick video with you calculating these. So there is more stuff involved in using trigonometry on triangles, but you know, this is a good place to start. So have a go, and you know, I wish you the best of luck. Thank you for watching.